Welcome to the Walton Pi. Today we are going to be talking about how to take the integral of a function that is comprised of trigonometric functions. So a useful spot where we can start discussing trigonometric integrals is to recall the derivatives of our six trig functions. So the derivative of sine is cosine, and the derivative of cosine is negative sine. The derivative of tangent is secant squared, the derivative of cotangent is negative cosecant squared, the derivative of secant is secant times tangent, and the derivative of cosecant is negative cosecant times cotangent. So if we ever see one of these in an integral, so for example the integral of secant squared x dx, that's going to be tangent of x, because we can go backwards to get our integral. So if we were given the integral of secant of x times tangent of x, the integral of that is going to be secant of x plus c, because the derivative of secant is secant times tangent. We might also need to combine this with u substitution to be able to solve different trigonometric integrals. So for these, be sure to pay a lot of attention when you make your substitutions, because it is very, very easy to have a sign error crop up. Because if we go back to the derivatives, there are a lot of negative signs. So for example, if you ever make the substitution u equals cosine of x, be very, very careful that your du is negative sine of x dx. That is a spot where you can get a lot of different sign errors that can come out. So when you are making your substitutions, be very careful when you're doing them, because it is very, very easy to have a sign error come up. And that's one of the very common errors that students will have when they are doing these sorts of problems. So let's do an example of a u substitution with a trig integral. So what is the integral of sine to the fourth x cosine x dx? Well, since we have sine of x to the fourth, that's probably going to be our choice for u. And if u is sine of x, then du is cosine of x dx. If we were to then make that substitution, that becomes the integral of u to the fourth du, which is u to the fifth over 5 plus c. Now we can't stop here. We have to replace u with sine of x again. So it is a 1/5 sine to the fifth of x plus c. That is the integral of sine to the fourth x times cosine of x dx. Let's do another example. What is the integral of secant cubed x tangent of x? Now, since we have both secants and tangents, a derivative that involves both of those is the derivative of secant. The derivative of secant is secant x tangent x. So if we make u secant of x, then du is going to be secant of x tangent of x dx. So breaking it up so that we have a secant of x tangent of x piece, what's left is secant squared of x. So making our substitution is going to become the integral of u squared du, because secant squared of x is u squared, and then secant x tangent x dx, that is our du. So the integral of u squared du is 1/3 u cubed plus c. Since u is secant of x, we get a 1/3 secant cubed of x plus c. If we were instead given the integral of secant to the fourth x tangent squared of x dx, this we might want to just try the same substitution. So if we make the substitution secant of x, by pulling out the derivative of secant of x, which is secant x tangent x dx, by pulling that out, we are left with a secant cubed x and a tangent of x. This looks like it's going to be a bit complicated because we have to somehow write tangent of x in terms of secant of x, which is possible, but it looks like it's going to be pretty ugly. So we might not want to try this substitution. Instead, we might want to try the substitution u equals tangent of x. If we make u equals tangent of x, then du is secant squared of x dx. So that means we're going to want to pull out a secant squared of x dx, so we are left with secant squared of x tangent squared of x. Now, we do still need to replace the secant squared of x inside the parentheses with something in terms of tangent of x, but this substitution is a lot more straightforward, because secant squared of x is equal to 1 plus tangent squared of x. So by making that substitution, we can now replace all of the tangents with u's and the secant squared x dx at the end with du. So that means we are left with the integral of 1 plus u squared times u squared du, which is the integral of u squared plus u to the fourth du. This is going to be a 1/3 u cubed plus 1/5 u to the fifth plus c, and now we can replace all of the u's with tangents, so the integral of secant to the fourth x tangent squared of x dx is 1/3 tangent cubed of x plus 1/5 tangent to the fifth of x plus c. That is how we are able to use u substitutions on these. If you aren't able to figure out these sorts of things, try writing everything in terms of sines and cosines, and then see if you can make a substitution of either u equals sine of x or u equals cosine of x. I hope this video was helpful. Please check out some of my other videos, and please like and subscribe if you haven't already, because that really does help me out quite a bit to be able to continue to make these videos. Have a great day, and good luck with the rest of your math.